all. My lecture series of Automata Theory and Compiler Design. I am Vinodhini. Today's class we are going to see about what is the difference between the finite state automata and deterministic finite state automata with an example. In the last previous videos we are see about what is an automata theory and what are all the types of grammar and what is a finite automata. The basic example of a finite automata. All we know that what is a finite automata. Finite automata, it is consist of the 5 tuples. We have a starting state, ending state, and set of input symbols and set of states and then transitions. So these are all the basic terms of we have a 5 tuples in finite automata. The finite automata is divided classically divided into the two types. One is the non-deterministic finite automata and second one is the deterministic finite automata. Based upon the input symbols transition to the next state, this classification is done. First we will see that in the last video we have seen that deterministic finite automata and non-deterministic finite automata. So in the non-deterministic finite automata we have that also have the 5 tuples like set of states, set of input symbols, and the transition function move then map from one symbol to the pair of set of states. So this is the main statement differ from the NFA to DFA. And next is a starting state, and finally we have a final states. So in the NFA is represented either by the transition table or the adjacency list representation. We are representing the non-deterministic finite automata. For example, consider this diagram. So this is the diagram for the regular expression which accept this diagram accept the regular expression of A or B closer followed by the A B B. So this is the diagram for that regular expression. So what is a non-finite deterministic finite automata means? For a single input symbol there is a move from a single input symbol to the set of states. Not a single state, it is a set of states. For example, consider for a input symbol A from the starting from the state 0, it goes to the two different states. One is the 0 when the state 0 it read the input symbol A, it goes to the same state. Then from the state 0 you are reading the input symbol, it goes to the state 1. For a single input symbol from a single state it goes to the two different states. So this is the main difference in the non-deterministic finite automata. So the finite automata is represented in terms of the transition table. For example, the transition table consists of a set of it contains 3 columns, that is the states and what is the input symbols and how that it is transition from which state it goes to that input symbols. For example, from the 0th state, we have the input symbol A and B transitions. When you read the A, it goes to the either 0 or 1, and when you read the B, it goes to the 0th state. So from the state 1, when there is no input symbol of A transition, only we have a B, and also in the 2 and 3, we have a 1 and 2, we have a input symbol of B. So this diagram representation is represented by using that transition table. Next is the deterministic finite automata. So the difference between the non-deterministic and deterministic is that the deterministic finite automata from a single state for a single input symbol it goes to the single state only. So the difference is shown in that transition table. So in that NFA transition table for state 0 for the input symbol A we have a set of states. But this DFA transition table for each state for each input symbol it goes to the single state only. So this is the main difference between the DFA and the NFA. This example for that DFA diagram that accept the string ending with 0. So the set of all strings ending with 0 means what are all the strings we can derive from that? Either first the input symbol is 0. So next is a 0 0 and 1 0. And the next in the two symbols transition 0 0 1 0 and this is the things, but the ending with the ending symbol should be the 0. So this is the diagram for that DFA for the given language. So in that for a single 0 it goes from the 0th state to, when you read the 0 it goes to the 1. For example, 0 0 means we have a self loop in the end state, and suppose after the 0 when you are going to read means it goes to the again 0th state and read that input symbols. So this is the DFA diagram for that given language. So next example for the DFA is a set of strings over a length 2. So what is the thing means the language should contains only the length of two symbols from the set of strings 0 and 1. And what is the thing? This is a finite automata. It is a finite symbols, finite set of languages 0 0 1 1 0 1 1 0. These four transitions should be in that set of languages accepted. So this is the example diagram for the DFA. So in the DFA mainly we are used in that lexical analysis in the compiler, and next is a spelling checker, we are using that DFA diagram, and the search command we are using that DFA diagram. So these are all the applications of DFA. So in this video we hope we are understand about what is the difference between the NFA and DFA, and the difference in that transition table only. So and also we have seen two different examples of the DFA. Thank you.